Welcome again, dear students. Myself, Dr. Kaleem Ahmed, Assistant Professor, Department of Wildlife Sciences, Aligarh Muslim University, Aligarh. Now, in today's lecture, we will discuss impact of urban heat island on biodiversity. Actually, this presentation will focus on understanding how urban heat island affects urban biodiversity with a focus on both flora and fauna. We will also try to explore the urban heat island phenomena, its specific impacts on various species and what it means for actually urban ecosystems. Let's start from the introduction to the urban heat island. The urban heat island effect, we can say, is a phenomena where urban areas experience higher temperatures than the nearby rural areas. The primary cause includes dense infrastructure, heat retaining materials like blacktops, and lack of the green spaces are some of the factors. On the basis of that, there is urban heat island effects. Urban heat islands actually impact not just local climate, but it also affect the urban biodiversity. And it is estimated that the urban heat islands can increase the urban temperatures by 2 to 7 degrees Celsius. So, it is a growing concern, we can say, as cities expand and climate change intensifies due to urban heat island effects. What is actually urban biodiversity itself in context of the urban heat islands? Urban biodiversity actually refers to the variety of the plants, animals and microorganism species in the urban ecosystems. It is critical for sustainable cities and improving quality of the life for the residents because of the ecological services it provides that include we can say air purification, pollination and number of the aesthetic values. Urban biodiversity, we can say, is also essential for ecosystem stability, and many species, we can say, in the cities have adopted uniquely to the urban environments. So, we can say creating some kind of the new ecological interactions in the urban environments. It is, we can say, how this UHI or we can say urban heat islands actually influence the urban flora. It is found that higher temperatures due to urban heat island stress on plants in urban areas impacting the growth of the plants of the different species. It also leads to increased water evaporations, placing some of the plant species under water stress. Urban heat islands also actually alter the timing of the flowering and the fruitings of some of the trees. Thus, we can say they disturb the natural cycles or the natural biodiversity that are surviving in the urban ecosystems. Even we can say the efficiency of the photosynthesis is also going to be affected by the extreme heat which reduces the carbon storage capacities in the urban heat islands. Urban plants, we can say that actually tolerate heat, often replace that cannot adopt the urban heat island effects, leading, we can say, to the shift in the plant compositions in the urban environments. Some plants actually, we can say, developed increase heat tolerance over time to survive to the urban heat island affected areas. So, some of the examples of we can say heat tolerant trees we can commonly seen in the cities include the London plant trees, and we can say the certain oak species are also actually tolerant to these urban heat island effects. Urban environments can also influence, we can say, plant genetics, leading to the we can say plant heat adaptations, while some of the plant species have also been found to adopt. Not only we can say native species survives, leading to reduced native biodiversity. Urban environments can also influence plant genetics, leading to heat adaptations. While some plants adopt, not all native species survives, leading to reduced native biodiversity. So it is very, very important to choose resilient plants for urban landscape for maintaining the greenery as well as the urban biodiversity. Trees and we can say and the green species play a crucial cooling role in the urban environments by providing shade as well as the cooling through evapotranspirations. We can say the challenge that the trees face in urban heat island areas include, we can say, soil compactions, increase water demand, and lot of we can say heat stress is there in these urban heat island areas. We can say green spaces including parks play some of the crucial role in moderating the local temperatures, and we can say also say that the trees and the plants also help, we can say, counteract UHI or urban heat islands, but require, we can say, it also requires some kind of the careful management and the support to thrive. Healthier, we can say, urban forests can also help to cities mitigate the worst effect of the urban heat islands. Another change in the urban flora compositions, the urban heat islands, we can say, also leads to shift in urban plant communities towards more heat tolerant species. You can find in those areas or in those regions where there is a effect of UHI, you can find some kind of the monotonous species in that particular areas. So we can say native species actually struggle in these areas with high temperatures, actually often replaced by the non-native or invasive species. Non-native species can spread in this area very, very rapidly, thus disturbing the natural balance and also affecting the local wildlife and the local biodiversity that actually thrive in the native ecosystems. These kind of things actually shift. There is a, we can say, there is a shift in decreased native plant diversity, and there is an impact on the overall biodiversity in the urban areas. This also thus we can say reducing UHI or urban heat island effect is also crucial in maintaining native plant population or native plant compositions. Another is pollination and seed dispersal change due to, we can say, urban heat islands. Urban heat islands also impacts pollinators, the species which are very, very crucial for the ecosystems like bees and the butterflies and number of the bird species, as they are very, very sensitive to heat change. The urban heat islands alter the flowering as well as the fruiting times that disturb or disrupt the pollinator cycles, thus affecting the pollination success. We can say change in the animal activity due to these heat can also impact the seed dispersals, especially for the animal, for those animals that actually totally dependent on the fruits. We can say the overall impact is on plant reproduction and the biodiversity, as these natural processes are disruptive due to the urban heat island effects. Another is impact on urban fauna. There are, we can say, direct and indirect effects of urban heat islands on urban animal species, especially we can say those sensitive towards the temperatures, towards the rising temperatures. We can say the thermal stress can affect animals' metabolic processes and also cause health issues in number of the, we can say, animal species. Animals also might change their, we can say, behavior due to these UHI, such as, we can say, shifting activities to cooler parts of the day. So we can say due to these fragmented habitats and reduced green spaces, isolate some of the species, thus intensifying the UHI or urban heat effects on the urban biodiversity. We can say the birds, the small mammals, and number of the insect species are often the most affected species by the UHI, urban heat islands. Species, there is also species distribution shifts. Species distribution shifts also occurs as animal seeks cooler environments, often outside urban heat zones. And some of the animal species we can say are limited to urban refugia or isolated cool zones within the city. So we can say heat sensitive species we can say might disappear from the cities due to lack of the adequate cooling zone in these urban areas. So we can say biodiversity is actually hence reduced as species either leaves urban areas or fail to survive in these areas. This we can say these kind of the things marks the importance of creating some kind of the green spaces to support the broader range of the species so that the biodiversity can also thrive in these urban ecosystems. There is also impacts of on nocturnal and diurnal animals due to these UHI urban heat islands. Nocturnal animals we can say suffer from warmer nights due to urban heat islands, thus actually disrupting their activity patterns, and diurnal animals also sometimes actually shift their behaviors to avoid the peak heating periods, thus impacting their feeding and the reproductive cycles due to these UHI effects. So these changes we can say in activity also impact the predator-prey dynamics, thus ultimately affecting the urban food webs at the larger scale. So we can give some of the specific examples include the we can say urban bats, the species which are actually adopted to the urban environments like urban bats and the owls are the species which are actually primarily impacted by the higher nighttime temperatures. They actually shift the entire behavior, entire activity due to these UHI effects. Fragmentation of the we can say habitats in urban areas, we can say UHI or urban heat islands also intensify its habitat fragmentations by creating isolated we can say green species as urban islands. We can say the fragmented habitats also lead to limited movement and gene flow among species, thus making small isolated population that actually face the higher risk of extinctions due to non-flow of genetic diversity. Urban islands also reduce biodiversity we can say by creating boundaries between the species and the populations, giving rise to the need for connected green species to support species interaction and reduce the urban heat island effects. And that impact on aquatic urban species, it's not like that only terrestrial species are being affected by these UHI. The aquatic species are also being affected due to UHI, and these are some of the impact. This we can say the UHI heats urban water bodies also. Thus, we can say affecting the aquatic species like fishes, amphibians. We can say that as warmer waters has reduced oxygen level and thus creating some kind of the stress to the aquatic life and disturb the entire aquatic ecosystems. We can say these temperatures can cause some kind of the harmful algal blooms, thus harming the biodiversity of that particular wetlands and the particular aquatic ecosystems. Amphibians, we can say, are particularly sensitive to the temperature change. Hence, these are the species that actually face direct decline due to these urban settings. So, we can say the managing water temperature through vegetations can also support the urban aquatic species. Another is increased risk of invasive species. Although we have discussed these things in the previous slides, but let's discuss some more thing regarding the increased risk of the invasive species. Warmer urban climates also we can say allow certain invasive species to thrive, thus then actually disrupting the local ecosystems. These species we can say often outcompete native flora and fauna for the resources. Some of the example like pigeons or the rats adapt well to the warmer, food-abundant urban environments. The invasive species change the predator-prey relationships and reduce the native biodiversity entirely. We can say thus giving rise to the need of controlling them to support the local biodiversity. Effects on insect populations. We can say the UHI also affect the insect populations, thus because they actually altering the life cycle and the distributions. As warmer temperatures favor pests like mosquitoes, which then proliferate in warm urban areas. We can say the pollinated insect like bees are negatively impacted, thus actually affecting the urban agriculture ecosystems. So we can say altered insect dynamics impact the plants and the animal relying on the insects as a food source, because everything is linked with the others ones due to various food chains and the various food webs. So we can say the need for the pollinator friendly practices to support biodiversity is very crucial if we really want that the insect population can thrive in the urban ecosystems. Consequences for the we can say ecosystem services, because urban environments also provide a lot of ecosystem services. We can say due to reduced biodiversity also reduce ecosystem services in the urban settings like air and water purifications. And there are a number of the other ecosystem services are also being affected due to we can say these UHI. Reduced vegetations also lowers the natural cooling effect. Thus, we can say exacerbating the UHI, since less plant diversity impacts carbon storage, reducing cities' ability to combat climate change, and also decrease the pollination effects urban agricultures, impacting local food resources, thus directly affecting the urban residents and the urban biodiversity. Adaptive measures by flora and fauna, we can say there are a number of the adaptive measures, behavioral change in the animals such as altered feeding or mating times. There is also physiological adaptation like increased heat tolerance in the plant species. Now, we can say not all species can adapt to these changing temperatures, which actually leads to decreased biodiversity. Thus, we can say the conservation efforts can only support to these adaptive species. What are the future outlook for urban biodiversity with UHI? UHI is likely, we can say, intensify with continued urban expansions. It's not like that they are going to be reduced, it's going to be increased day by day. And some species may continue to adapt, but many will struggle due to this UHI effects. So we can say thus UHI management is very important for biodiversity resilience. We can say the future research and the policies efforts can support the urban biodiversity, as sustainable urban planning is key to balancing the development with biodiversity. Another, we can say urban planning for green infrastructure. There are other things that one can do. We can do the green roofs on the walls. So these can help reduce UHI effects by absorbing the heat and providing habitats for the urban wildlife. We can also do the incorporating green spaces into the buildings, and the other infrastructures may become more widespread as cities focus on actually sustainable developments. Another we can do is biodiversity corridors. Future urban planning will likely focus on creating ecological corridors, means connecting parks, wetlands and other green spaces to allow species migration and also reduce the negative impacts of the habitat fragmentation. Another we can say is water features. Restoring and preserving urban water bodies can also provide critical habitats while mitigating the heat through evaporative cooling. Another we can say is increased use of these native and heat resilient species, as we can say cities look to mitigate the UHI effect and its urban or its impact on biodiversity. They will likely to prioritize planting native and drought tolerant species and heat resilient species in the urban landscapes, because these things will help sustain local ecosystem and reduce the need for resource intensive maintenance. Another we can say is climate change and UHI interactions. We can say these interactions between the climate change and UHI could intensify the challenge for the urban biodiversity, As global temperature rise, urban heat island may further worsen the heat stress on the species. So we can say cities will need to adopt mitigation strategies quickly to prevent the biodiversity losses. Urban planners need or may need to account for not only the current temperature but also projected future climatic conditions. Another we can say is one can do is technology solutions in the smart cities. We can say that advanced technologies like smart sensors and the climate monitoring can help cities respond to the UHI effect in real time. Thus, by adjusting water irrigation, shading systems, or implementing emergency cooling measures in the wildlife habitats. Smart city frameworks may also involve the use of the data to optimize the placement of the green spaces for maximum ecological benefits. Another we can say is public engagement and the policy change. Policies aimed at reducing the UHI effects, such as cooling requirement for the new buildings, stricter regulations on the waterproof surfaces, and initiatives. These initiatives to increase urban tree canopies will likely to become more common in the near futures. We can say community involvement is another thing that one can do to reduce the effect of UHI. In greening the projects crucial in maintaining the biodiversity also. As people, more and more people can aware of all these things, we can actually protect and restore the natures in the cities. So that the biodiversity can thrive and the people can also live in harmony with the natures. So we can conclude to today's presentation because as the future of the urban biodiversity in the context of the we can say UHI effect will depend largely on the proactive urban planning and the integration of the green infrastructures. We can say that while UHI presents challenge, especially in the face of the climate change, cities that prioritize ecological connectivity, green spaces, and heat mitigation strategies can still support diverse species and the ecosystems. We can say the key will be creating urban environments that are adaptable and resilient to the growing stresses of the heat and the urban expansion. With this, dear students, we end today's lecture, and in the next lecture we will continue to discuss some other topics. Thank you very much.